Okay, 5.2, day 1, the natural log function and integration. So yesterday we developed the techniques to derive the natural log function. And we said the derivative of the natural log of u, or the absolute value of u, was 1 over the expression times the derivative of the expression. Okay, now suppose we want to integrate both sides of this. So the antiderivative of 1 over u du, we know that the antiderivative and the derivative are inverses of each other. So according to this rule, the integral of 1 over u du is the natural log of the absolute value of u plus c. Now, why is the absolute value necessary? We know the domain of the natural log function is all positive values. So we can't take the natural log of 0 or the natural log of a negative number. So we need this condition when we integrate. So this is our log rule. And this rule completes our power rule. So we know we have our power rule for integration. We add 1 to the exponent and divide by the nu, and we add c to that because it's indefinite. But up until now, we always said n couldn't be negative 1, because if n were negative 1, it would put 0 in the denominator, which we know isn't true. So now, if we want to integrate 1 over x to the n power, okay, we would write that as x to the negative n dx. Now, if n is equal to 1, we have the rule that enables us to integrate this. So it's not the power rule where we add 1 and divide by the nu, but it would be the natural log of the absolute value of whatever that u would be. Okay, so we call this u. So then we would have u to the negative first. And now when we integrate anything to the negative first power, it would be the natural log of u plus c. Okay, and if you printed the slide, you'll see that we'll just practice this with a bunch of examples. Okay, so the antiderivative of 10 over x. I would pull 10 out. I know you guys ask me often, do we have to do this? It's totally up to you, but just so you can see the rule, 10 is just a constant, or a coefficient, I'll say. Now, I'll do it for this one. If we rewrote this as a power rule, x to the negative 1, all right, we can't add 1 and divide by 0, so this is our log rule, absolute value of x plus c. Now, as we do these, maybe after the video, if you want to check your answers, 10 times 1 over x plus 0. So 10 over x is our original integrand. Now, for here on, I'll go right from this step to the antiderivative. Okay, so I need you to recognize the 1 over x to the first power would just be the natural log of x when we integrate it. Okay, 1 over 4 minus 3x. So now we combine this with u substitution. So we're going to pick u to be our entire denominator. Du is negative 3x dx. Dividing both sides by negative 3x. So this becomes 1 over u. Oh, this is wrong. The derivative is just negative 3. Sorry about that. Times du over negative 3. So this gives me negative 1/3 antiderivative of 1 over u du. Negative 1/3 is our coefficient. Antiderivative of 1 over u is ln of the absolute value of u. So then our last step would just be to replace u with our substitution. A lot of you ask me, how do I know it's a u substitution? Look at x. If you think about deriving where x is, it has a derivative that's not equal to 1. Whenever that's the case, you have to make a u substitution. So the only place we would start here is by picking the whole denominator. Okay, so again, start with a u substitution. When I look at x, its derivative is 2. So I'm going to pick the denominator. That makes du 2 dx, dividing both sides by 2. So now we're going to look at the rule with a definite integral. Okay, we bring the 1/2 out front, -1 to 1 over u du. The antiderivative of 1 over u would be the natural log of the absolute value of u. I don't need plus c because it's a definite integral. So 1/2 ln of the absolute value of 2x plus 3, and I'm going to evaluate that from -1 to 1. So I like to keep the coefficients out front. Natural log, when I plug 1 in, 2 plus 3 gives me natural log of 5, minus the natural log. When I plug -1 in, -2 plus 3 gives me 1. So 1/2 ln of 5 would be my final answer. We know the natural log of 1 evaluates to 0. You could write this as the natural log of 5 all divided by 2, but you can't tell me it's the natural log of 5 divided by 2. Okay, it's the natural log of 5, and then I'm dividing that answer by 2. Don't know how many of you like to change the boundaries, but if x is equal to -1, then plugging -1 in for u, 2 times -1 is -2, plus 3 would give me a u of 1. When x is equal to +1, I get u to equal 5. So we saw this on the practice test I gave you. You saw this, I believe, on the midterm. The true u substitution would be 1/2. -1 in terms of u is equal to 1. When x equals 1, u is equal to 5. Changing the boundaries just eliminates u having to resubstitute in at this step. So instead of changing u back to be 2x plus 3, we can just keep u because our boundaries are in terms of u as well. And you'll see we get the exact same substitution. Okay, so 1/2 ln of 5. Solve the differential equation, dy dx equals x minus 2 over x, whose graph passes through -1, 0. So we know this is the derivative. Graph passes through this point. Given a point, we're going to be able to find the particular solution. Okay, so multiply both sides by dx. Now we integrate both sides. The antiderivative of dy is y. I'm going to split this integral up by dividing both terms of the numerator by x. X divided by x is 1, minus 2 over x. Okay, the antiderivative of 1 is x, minus 2, natural log of the absolute value of x, plus c. Okay, where did this answer come from? If I look at this as antiderivative of 1 minus 2 times the antiderivative of 1 over x dx. -2 is just a coefficient that can be brought out front of the integral, and then I'm integrating 1 over x, which is natural log of the absolute value of x. Now let me plug in my particular solution. Y is 0 when x is -1. Absolute value of -1 is 1. Natural log of 1 is 0. So c is equal to +1. Therefore, my solution would be that final answer. Antiderivative here. So I have an inside function. I'm going to pick u to be that 9 minus x squared. du is -2x dx. Dividing both sides by -2x. So antiderivative square root of u times du over -2x. I picked the right u because my x's cancel. -1/2 antiderivative of u to the -1/2 du. Okay, so this antiderivative is not the log rule, and that's what I need you guys to see. This is just one of many rules we have for an integration. It doesn't mean every single problem will use that rule. So -1/2, add 1 to the exponent, divide by the new. It's indefinite, so I need the plus c. The 2's cancel, and I get negative square root 9 minus x squared plus c. So that would be my final answer. Okay, now we get into the good stuff. Let's see here. Let me pick my u to be x squared plus 3. It makes du 2x dx. So we've talked about this. If I make the denominator u, okay, so that'll just be substituted in with u. Look at all these pieces I have in my numerator. That single x is not going to cancel out those x's. So that's no good. Okay. The only other option we have then, what about the numerator as u? Okay, that makes du 3x squared minus 6x plus 4. Okay, so if I eliminate the numerator, I'm going to replace that with u. Now, I don't have this many terms left in order to cancel. All right. So what to do? When the degree of the numerator is greater than or equal to the degree of the denominator, simplify using synthetic or long division. I know you're going to love this. The degree of a polynomial is the highest exponent. So the degree of the numerator is bigger than or equal to the degree of the denominator. You have to simplify the integrand before attempting to integrate. All right, good old long division. You need long division because the divisor is not linear. Okay, so synthetic is only for linear divisors. All right, divisor. So x cubed divided by x squared gives me x. Divide, multiply, x times x squared is x cubed. X times 3 gives me 3x. Subtract the terms. They cancel. I have to bring down the negative 3x squared. 4 minus 3x gives me a positive x. Bring down the negative 1. Repeat the process. Negative 3x squared divided by x squared gives me a negative 3. Negative 3 times x squared is negative 3x squared. Negative 3 times 3 is a negative 9. Subtract the terms. They cancel. I bring down the 1x, and that becomes 0. Okay, when the remainder's degree is less than the degree of the divisor, I can't divide anymore. So now my original integrand is simplified to the antiderivative of x minus 3 plus the remainder over the divisor. Now, what I can do is integrate each piece of my integrand. Okay, I'm going to exaggerate this so you see it step by step. Antiderivative of x, that's just a straight application of the power rule. X squared over 2 minus antiderivative of 3 is 3x. Now when I integrate this, I need another u substitution. So I'm going to pick u to be my whole denominator, which makes du 2x dx. Solving for dx. So that gives me plus antiderivative of x over u times du over 2x. The x's cancel. Minus 3x plus 1/2 times the antiderivative of 1 over u du. So what's my final answer here? Complete that for homework. Those of you that print the slide, you'll see there's more examples, but we'll continue with them in class.